It's based on a 2022 Toyota GR86, thing that you can take to the track and actually spend the weekend racing. There's no turbo spool up, there's no supercharger. Motor is a stealth EV motor. Its potential is about 500 horsepower, about 550 foot-pounds of torque. There's a dry sump oil tank in the back here. These are the oil coolers you'll see in the back here. So we run their standard 5-pound fire suppression bottle.
So tell me, what are we looking at?
Okay, so what you're looking at is the Scalar SCR1. You'll be familiar with, it's based on a 2022 Toyota GR86. That's the platform that we started with. So it rolled off the showroom floor. It's a full trim, like as you would buy it from Toyota, full interior. It has 161 kilometers on it. We're Canadian, so
okay.
161 kilometers on the dash. When we completely tore it apart and started our venture with converting this to an EV race car. So how we kind of came up with this idea is we were endurance racing and we had no problems with the chassis of the car, but motor problems. If our motor wasn't out of the car, a team's motor was out of the car, or ICE engine was out of the car.
Sure.
So like, wouldn't this be great to like not have problems with an ICE engine? Like what's the other alternative? And then, well, one of the other founding partners already had a Tesla, and it's like, well, electric, there's no maintenance to it, there's no cost to it. Like it just works. There's only one moving part, the rotor and some bearings. Like it's really the solution. The battery is kind of the only thing to work around for as far as for endurance. But so what we wanted to do is we wanted to have, from a racer's perspective, because our background is racing, we wanted something that is a thing that you can take to the track and actually spend the weekend racing. Like that's kind of our funny thing. Imagine going racing and actually racing,
and not spending
time, not wrenching on the car, not pulling the motor out, pulling the transmission out, pulling the drivetrain out. So we came up with the solution of an EV swap, and the torque on demand is just so amazing. Like you instantly press it. There's no turbo spool up, there's no supercharger, there's no, it's just all the power right away whenever you want it. You're not shifting gears, you're not worried about the power band, you're not worried about all these things where it's just, as far as a driver, it's point and shoot, and you can really focus on, put your attention on where the car needs to be on the track. You're door to door with another person. You can focus on really going door to door with them and making that line count and trying to pass the person, not worry about, oh shoot, I got the wrong gear, and then they start pulling on you. No, it's none of that.
I love it.
That's how we approached it with this. And we picked this car because, one, from an aftermarket standpoint, there's a lot of support for it. There's a lot of options out there as far as brakes, tires, wheel setup, configuration, control arms, differentials, like body work. There's so much that if you put this thing into a wall, you can go to a wrecking yard and get another piece for it. It's still all GR86 components. So I'll walk you through the car. We'll kind of start at the front here. You'll notice that there is now not a boxer, but it's a box. So this is the beginning of our battery pack that starts up in the front. And it's funny, me being a Subaru guy, we've solved the Subaru boxer problem by basically converting it to EV. That's a funny joke that we say.
Getting rid of the boxer.
Exactly. How do you fix the boxer problems? You get rid of it. So up at the front, there's the beginning of our battery pack. So it's shaped like a T. It starts in the front of the engine bay, and it goes up the transmission tunnel, and then ends in the back seat. So your center console is actually now part of your battery.
Wow.
So now, because the space claim that the battery takes up, it's obviously, you're cutting out a lot of the car now. So the battery is actually structurally integral to the chassis of the car. So what we did is we avoided all like the frame rails per se. It's a unibody car, but all the structural members, avoided all those, cut out all the floor pans, and then the battery is all tied together on the bottom of the 1/4-inch aluminum skid plate. So not only have you now just tied the entire bottom of the car together with a big aluminum skid plate, it's now a perfectly flat bottom car, which in racing is perfect. Aerodynamically, that's exactly what you want. So with a flat bottom car, we gave the car about 1 degree of rake, tied in with the diffuser we have at the back. So now we don't have an exhaust back there. The whole car acts like a big diffuser, and aerodynamics was super easy to set up on this car. We actually had the car at the one of the best wind tunnels in North America at Ontario Tech. So we put this in the wind tunnel and tested all the aero on it.
Yeah.
And it was amazing just to see the benefits of having like a flat bottom car and how you can tie the aero into that. Because the thing with the
CD. rating on it?
We did. I don't remember it. It's in,
Okay.
I think it's in the video though, if you want to check it out. Yeah, it's good. Well, actually, it's not as good as it should have been. We made a whole bunch of improvements. One of them was that actual 1-degree rake in the car. That was something that we found to maximize potential of the flat bottom. Give it that rake. We didn't have that in the video.
Got it.
So there's a bunch of takeaways that we took in that video that you'll see that we've now applied. Even something as far as like a window net in the car actually is huge aerodynamically. Who would have known? Obviously, windows up in a car is good for aerodynamics, but who would have known a window net would have offered about the same aerodynamics, because it actually affects how the rear wing interacts with the wind coming off the car.
Sure.
But one of the nice things about being electric, the possibilities, combinations of where you put your powertrain is really endless. Like with the original powertrain, started in the front, it occupied the transmission tunnel, took up the back. So that's quite a bit of a space claim for the drivetrain, right? Whereas a motor, you have this motor that weighs like 80 pounds that we have in the trunk, and you can see it through the back window. We actually set it right on top of the subframe. So the motor, because it doesn't take up much space, sits right over the rear wheels. So by locating components in the perfect spot, we've actually achieved the perfect weight balance of 55% rear, 45% front.
That's amazing.
So the power, the weight balance is exactly that of like a Porsche GT4. So that's kind of the goal we wanted with this car, is to place the weight, the battery cells, the motor, everything, so that we got that perfect weight balance. So from a race car perspective, that's exactly what you want. It's an amazingly handling car. We have the exact same car in gas also, because we wanted to do some back-to-back testing. What's the gas one like versus the electric?
Yeah.
And this handles so much better than the gas car, as far as where you can put the power down, how you can come in on the trail brakes. You can apply way more braking in the rear because now you have more weight over the rear wheels. It's just handling wise is way better than the gas car, and we've done that by optimizing the weight place for the components.
Awesome. I love that. So let's go back to this battery pack.
Yep.
The way that it's tied in structurally is awesome. But what about inside this box?
So inside,
how big is the pack? What type of cells?
It's a 60 kilowatt hour pack. It uses lithium ion cells, so they're cylindrical cells. We have 24 modules. Right now it's an 800 volt pack. We opted for the 800 volt for one, you can charge faster and deliver power better.
Really? 800? That's cool. You don't see that a lot.
No, you don't. So Porsche Taycan uses 800 volt.
Okay.
Even the Porsche Performance, they're using the 800 volts. We really wanted to do 800 volt. You don't see it, yeah. Tesla, most road going vehicles are only 400 volt.
Right.
800 volt gets us the power we want, the delivery we want. So it was a bit of a challenge because 800 volt is so new. Like just for example, our DC to DC. Tons of 400 volt DC to DCs that you can get, but try and find somebody who makes an 800 volt DC to DC. It just was super hard to find. We had a big wait time to try to get it. I was actually, like, the entire time we were building the car, the DC to DC was like the last component that we actually could get. Luckily, Cascadia made inverters that handled up to that 800 volt. But just there were some challenges with choosing 800 volt, but we really, really wanted to achieve 800 volts with this car.
Awesome. And then, so we just talked about the inverter. What about the motor?
So motor,
let's talk about that.
Motor is a Stealth EV motor. So Stealth EV out of California made the motor for us. So power output right now, it's making about, or its potential is about 500 horsepower, about 550 foot-pounds of torque.
Okay.
So when compared to the gas engine, that's more than double what the gas engine offers. So right now we're not running it at that, because running it at that, well, you just kill the battery so fast. So it has the potential to deliver that power, but we're trying to find the balance, so this is part of the year of prototyping, the balance between what kind of power gets us the runtime we need with the battery and motor configuration that we have. So there's options that we looked at, probably doing like a qualifying mode where you have all the power, or all the beans we call it, where I just want to do, I want everything this thing will give me. But that's the nice thing about electric. If you just want to, maybe the class you want to race in is you want to try a slower class. You're new to racing, right? You don't want to race with the speed that this car can do. You want to start out easy, like with a Miata Cup car or something like that.
Yeah.
So let's just dial the power down. Super easy to do with electric. Gas is a little more, you gotta have multiple tuning maps, and that this is just simply, okay, just current limit. Like, that's super easy. So that's another nice thing about electric. But yeah, this motor is, we worked really closely with Stealth EV to develop, it's a new housing with a Borg-Warner motor core. Okay. It's a dry sump system, so something that you're not familiar with seeing on EVs, there's a dry sump oil tank in the back here.
That's awesome.
So there's a Messier pump, scavenging pressure pump underneath that supplies oil for lubricating and cooling the motor. These are the oil coolers you'll see in the back here. And so only the motor is on the oil cooling loop. The inverter back here in the battery is on its own water loop.
Okay.
So they are cooled up at the front, and then the motor is cooled up here at the back.
That's really cool.
Yeah.
I've never seen that before.
Yeah, so and even to that point, the Peterson, there's a guy here from Peterson Oil Systems. He walks up to us and he's like, I walked up to your car and I saw a dry slide. I'm like, I've never knew this was a thing.
Yeah.
So like, yeah, it's a thing, and it just makes perfect sense. So now the motor, pretty much put it wherever you want, and as far as cooling and lines and that, just run some AN lines to it, and it's super easy to place where you want to put your components.
That's really cool. I mean, dry sump you hear about in ICE cars.
Yep.
When you start going fast enough, you need it.
Yep.
But now we have it for EVs too.
Yes, and the motor, it's mostly for cooling. I mean, the lubricating needs for that motor aren't very high. It's just 2 bearings on the end of it. And as far as like getting back to the maintenance and serviceability, this motor needs the bearings changed like every 1,000 hours. So like, basically there's no maintenance, right? You have no combustion gases going into the oil. So the oil, like maybe just for the sake of it, maybe getting a bit dirty, change it like every year, every 2 years. But maintenance on this car is next to nil. Like that's the nice thing about this car is the maintenance cost is low. Whereas other race cars, ICE cars, the biggest expense is usually maintaining the car, not buying it. Buying is the cheapest part, and then maintaining it every year is what costs the most. So really all you need is brakes and tires, and to that, you don't even really need to do rear brakes because this has regenerative braking. So we use regenerative braking for the back, only on the back wheels. We've experimented this year with running no brakes, small brakes, and super big brakes. So judging by what levels of power or what levels of charge we need to go out with the battery, depends on how much regen we can put into the battery. So what is that top part of the battery worth as far as like how long it lasts? Throughout the race, that top 30% is worth more than the bottom 30%. Yeah. So do we go out with a higher charge, run big brakes, or do we run no brakes, slightly less charge, and then full regen? So again, things we're learning this year in prototyping. So trying a bunch of different things. With EV, you can there's so many different things that you never even thought of. That's so cool. So
let's talk about how you make those changes. The brains of the car, right? You have a vehicle control unit, something like that in here.
As far as vehicle controls, so it's actually on the passenger side here.
Good job, Jimmy.
How's it going? So on the passenger side here, you'll notice we have our VCU, and then we also have a PDM in there too for all of our low voltage controls. So we're running a VCU 300, and that basically is our vehicle control unit for the motor and inverter. And then for all the other electronics, we're running a PDM, an ECU Master PDM.
And there's a lot of additional software on here just for racing, right?
Yeah,
like
so
this.
I'll show you what we got going on here. So one of the biggest things with racing is, as a driver, you want to be able to improve yourself. You want to be able to improve your driving abilities, and you want to learn real time, is this lap a good lap? Is this corner I just did a good corner? Like, how am I behaving as a driver? So here we have our telemetry system. So this basically tracks the car exactly where it is on track, what your predicted lap time is, what your last lap was, and what your best lap was. So as you're going through the track, this will show you a time across the screen. And if you just did the corner better than you ever have before, all of a sudden it'll show you just took 0.5 seconds off your lap.
Nice.
So that's like, as far as driving like a driver goes, that's key.
Yeah.
So not only is the car super easy and friendly for you to learn as a driver, it teaches you live while you're driving. If you're doing the right line, if you're doing a good lap time.
So you can try something and then you get a green plus like negative 0.05.
A green negative 0.05. You're like, oh, perfect. Yeah. So now you know I'm going to take that corner every time that way.
Yeah.
And I've driven, so we also have this in our endurance racing car. I've been out on track for an hour and a half and almost at the end of my 2-hour stint. And then I'll try a corner differently, and all of a sudden it shows, wow, I just took half a second off, even though I've been out now, and then I apply that. And then, so over the course of your entire stint, you can really maximize how your track time is and improve your driving.
That's amazing. What other sorts of racing specific types of stuff? So obviously there's the roll cage here. That's part of the car.
Yep. So roll cage, you have your padding. Because this is a prototype, we actually run a mini PC. So there's actually a PC in the car right there on the floor. We have a cradle point in the back.
Help me out there. PC?
So like, that's a computer.
Oh,
That's like
actual.
That's an actual computer.
PC.
Yeah, like
Gotcha.
something that you would have on your desk. Personal computer runs Windows.
Okay.
So as the car is driving around the track, because it has a cradle point in it and it's connected to the internet, I can be driving and be like, oh, hey, radio in, the car is exhibiting some sort of symptom, and I can't see maybe specific diagnostic data, but I can have somebody in the pits log in and like, oh, there's this certain thing that, oh, 1 second, let me adjust it. Makes the adjustment, boom, car's back out again. So as far as a prototype goes, that's amazing for us to be out, me driving, or our driver is out driving it, and we need to make live adjustments to the car. So again, the car is always connected to the cloud. It's always, every second of its life, we know what's going on with it. Other electronics would be like, we have a radio, we have our fire suppression system. So I'll touch on the fire suppression system. This was a really big point that we worked with Lifeline very closely with. We wanted to follow the FIA standards as far as building an EV race car go. Okay. So our first step when we first conceived this idea was safety, because the reason that you can't race an EV right now wheel to wheel with other gas cars is safety. Because there's so many EV vehicles out there, you don't know if that one is going to go off track, crash, and burn for a week. And track owners don't want that. First responders don't know how to respond to it. Like, they're just not familiar with it. So when we approached NASA, we worked really closely with them in the beginning of this idea to make sure that we had a place, one, to run the car. Because when we come up with this idea, it was right in the midst of, tracks were banning EVs, EVs are not safe. And we wanted to squash all those ideas and be like, no, this is safe. It's just different. There's just different things that you need to know, different approaches and different tactics that you need to do when you build the car. So safety was our first priority in building this car and working with the organizations to make sure that we implemented everything. So that's why we followed FIA, which is why you see like an HV status light. So this light is green if the car is safe to touch. If high voltage is active, that light's green. First responders know if they approach the car that the car is safe to touch. I can handle it, I can pull the driver out, everything's good. If that light's red, that means there's a high voltage system fault. That could be either high voltage leaking into the chassis, or it could be a problem with the BMS system. There's something wrong with the high voltage, and that will trigger basically first responders to come up and push the e-stop. This is pretty standard procedure in a car, in an ICE car on a racetrack. You have an e-stop, the car's in an incident. Immediately, people go and push the e-stop because they don't know if the engine's running. They don't know if the fuel pumps are running. Yeah. Well, in this car, you don't know if the high voltage is active. I mean, we do have lights to make it obvious, but just as a safety thing, you press that, all high voltage is killed. All non-necessary 12-volt systems are also killed. The only thing that stays on is really the VCU and the BMS, just so we can keep monitoring the high voltage battery to make sure that it stays safe. So to the fire suppression system, like I said, we work with Lifeline. This is the only battery-powered vehicle that actually has fire suppression going into the battery pack. Now, is that going to stop a thermal runaway? No, we did math and calculated with Lifeline. The actual necessary volume that we need to actually sustain a thermal runaway and suppress it is so massive, like it's just not practical to carry it on a car. So we run their standard 5-pound fire suppression bottle. It's Novec 1230. If it does get deployed in the pack, it won't wreck the pack. It won't be a big massive cleanup mess afterwards. You can basically deploy it and then recharge a cylinder and the pack is still good to use. But what that does is, say you have an accident and there's a breach in the front of the pack. Say the first group of cells have been penetrated, are exhibiting a thermal runaway. You have that flare up, you'll have the initial sparks that come off the battery. Basically what that does is the Novec will suppress that flame, that initial flare up. It'll keep the area cool and chilled so the driver can get out, the car can get taken off the track and be put into a safe area where it's away from any spectators, bystanders, and it's not going to wreck the track. Because our motto is save the driver, save the track, save the car. So obviously we want to save the car if we can, but the driver is most important first of all, and we want to keep the track safe, because if the track's not in a good, safe condition, then they're not going to want these cars there.
Yeah. So another thing I notice is that the battery is really largely within the roll cage.
Yeah.
So as far as preventing against like a mechanical impact or something like that, that has to help too.
Yep, that was very important to keep the battery weight centralized to the car, not only for crash protection, but also for weight and balance of the car. Keep the center of mass as close to between the axles as you can. As soon as you have weight overhanging an axle in the front, overhanging in the back, now you have leverage that weight can exhibit on the rest of the chassis on the car when you go around a corner. You keep the weight inside the axles, the polar moment of the car is very central. So when you're driving it around a corner, it's very stable. Doesn't feel like it wants to slide out all the time. So crash protection and handling characteristics of the car was why we put it kind of in the location that it is.
Awesome. Well, there's so many systems and so much to this build. I don't think we can cover it all today, but when should people be looking to be able to buy something like this? This is the prototype.
Yep.
When does 001 hit the manufacturing?
So we have 001 and we have 002. 002 is currently being built in Prover right now.
Okay.
We can expect to see prototyping on both these cars done probably by the end of this year, maybe beginning of next year. Expect to be these cars for sale mid next year.
That's super exciting.
Yeah.
Thank you, Joel. I really appreciate it. And
Anytime.
we'll definitely be talking to you guys more soon.
Sounds good. Thanks.
Awesome. Bye.